Hi everyone. Today my presentation is on AI enhanced mental health risk analysis using social media data. This work was completed as a part of my research, MS research at the National College of Ireland. Here the study mainly focuses on integrating like sentiment trajectories, temporal posting behaviors, and social engagement features into AI models and for improving the mental health risk analysis and also for analyzing the mental health detections. I will outline the background problem statement, research methodologies, research, further future works, and conclusion everything in the following slides. And in these slides, the mental health disorder affects nearly 1 billion people worldwide every year, with the depression and anxiety being among the most prevalent. Traditional assessment methods are episodic, limiting earlier detections. Social media offers a unique, passive, and real-time sources of social behavioral data. Advance in AI and NLP enables like a meaningful analysis for unstructured text. Potentially, it identifies the psychological disorders. This creates opportunities for scalable, non-scalable monitoring for us. So we can complement critical assessment with adhering to ethical and private privacy standards. And coming to the problem statement, currently AI-based models, AI-based mental health analysis relies primarily on isolated text analysis, and it misses the broader behavior and temporal context. This often fails to capture how essential states evolves on the real time like social media apps and the person's emotions and everything. This results and reduce accuracy and interpretability. Here in this thesis, my project, addresses this gap by proposing a multimodal AI framework that integrates sentiment trajectories, temporal posting patterns, and social network engagement as well to improve the detection and explanatory powers. And coming to the research aim and objective, the primary aim is to design and evaluate a multimodal AI model for detecting mental health risks in social media users, those who are using the social media users for them. The objective are listed in 4 ways. The first one, 4 types. The first one was, 4 stages. The first one was pre-processing and engineering sentiments and temporal and social features for the labeled data sets. And the second one was implement and compare multimodals, machine learning and deep learning models. And the third one was access these against sentiments on baselines. And the last one was explore ethical implementation, ensuring responsible AI deployments. This comprehensive approach ensures both technical and practical analysis in the sentiment health context. Coming to the key concepts and terminologies, this study uses several key terms like sentiment trajectories. It refers like change in emotion tone over time in users posts. Like in every 1 hour or in every minute, the user will post different posts based on their emotions. And temporal posting patterns captures time-related behaviors such as late night activities. And here, like a social network interaction measures engagement levels such as retweets and followers, like how much he is in social media. And a multimodal classifier integrates the dimensions combining behaviors and temporal features to enhance predictive performance and interpretability. This defines provides clarity of for the components explained towards the research throughout the research and evaluation phases. Coming to the literature review and highlights. In the previous research papers which I have studied and I have focused, that transform models like BERT and RoBERTA outperforms traditional methods in depression detections. And LSTM based models effectively track emotional changes over time usage and also social engagement metrics such as community interaction and network centralized have been linked to psychological states. Explainability like frameworks like SAP enable ethical AI deployment by revealing decision-making process. However, Few students combine sentiments, temporal and social features, leaving a gap for integrated multimodal approaches in the mental health monitoring. Coming to the methodologies, in this study, I used like 20,000 anonymous tweets, English language tweets, yes, depressed or non-depressed, including like a metadata as well. Pre-processing involves sentiment scoring like temporal features, extraction, and social engagement measures. Three models I have used here, like logistic regression is used for baseline, and LSTM for temporal patterns, and digital BERT for deep contextual analysis. Evaluation employed accuracy projection, unlike a F1 score, AUS, and SAP explainability. These methodologies ensures as a balanced comparison between traditional sequence-based and transformed-based approaches for both performance and interpretability. Like coming to the code, at the starting, I have uploaded the data sets for the data loading. Here I have mentioned like def info, def head, like under def describe, like def info is used for to see the basic info of the data sets, and def head is used to see the first heading, starting headings of the data set, and def describes it used like to see the statistics and counted null values. And then I started cleaning the data sets. Here you can see everything. Def info, def describe, whatever the matters content in the data set. And then I started cleaning the data sets. Here I drop like unnecessary columns. Like here you can see like a unnamed equal to 0 to remove the irrelevant or reluctant data to keep like analysis clean. And here also and also here I use like a post create, like to create a proper date time format, because proper date time format is crucial for the time-based analysis. So I use like a post create. And also you can see here like a text length is used for the number of characters in the text. You can see here. Used number of characters in each text. This text length can as an important indicator like for expression patterns in the mental health context. And then coming to the exploited data analysis is used for to see the visual patterns. Here I got there like a plotted distribution for mental health labels. Here you can see 0 and 1. And 0 is for like a non-depressed and 1 is for depressed. Like a visual help detects class imbalance. Here I compare test length as well. Test length between the depressed and non-depressed tweets using like a box plot to see the behavioral difference in language length and engagement. And also here in a violent plot to compare retweets by labeling. And also here like in correlation heat map reveals like relationship that guides features selections. And I started like using like sentiment and temporal features. Is computed like a polarity and using like a text blob. Sentiment trends can indicate mental health shifts. And here you can see like a sentiment shift, changes in sentiment per user over time. I mean like over a period of time. And also I extracted posting hours and a day of week. It estimates a simple saturity measure for retweet pattern using the networks, and then I saved the pre-processed data. After that, I have used here you can see everything, and then I saved the file here. And then I started applying the models. Firstly, I have applied logistic regression model. This model encloses like categorical features. And here I split the data and split the data for training and testing, and it provides a transparent baseline model. Helps like set performance like benchmark before using more complex models. It provides like a transparent baseline model. And then I started like using like explainability of SWAP with SWAP. Used SWAP to understand feature contributions. To generated like a summary plots and bar plots for feature importance. You can see here everything, the plots. It improves like interpretability of prediction and also like essential for mental health applications where decisions of after individuals. You can observe here the graphs. And then I use the another model like LSTM model. It is used for like sentiment trajectories. It creates a sentiment sequence per user. For every user, it creates a sentiment sequence. Used padding for sequence alignment, used paddings, and then for trained an LSTM network to classify depression based on temporal sentiments. And then I use like a national BERT model for textual test classification. For the test classification, I use like digital tokenizer. Digital BERT tokenizer I use for the test classification, and then I trained for the data transform model with class weights to handle imbalance and then evaluate classification performance and combined AUG. For using all these models, we got like accuracy, like baseline logistic model gives interpretable results, but low accuracy. And LSTM improves prediction by using temporal sentiment shifts. It gives much. And at the last, BERT provides the best text-based performance. It gives the best text-based performance. And at the last, results and evaluation. As we see in the code, the logistic regression achieved more accuracy like 81%, less accuracy like 81%, and high interpretability through a SAP analysis. And LSTM achieves 73% accuracy, but suffered in limited historical users data. And the last one, BERT performs best. It performs the best, achieving highest accuracy like 91% and also 0.75 AUS. Demonstrating and conceptual understanding like comparative results shows that transformer-based models excels in extracting signals with traditional models offers interpretability. This finds validate the importance of multimodal features for enhanced accuracy and are also responsible for AI implementation in mental health as well. And then coming to the discussion and implications. This findings confirms that integrating sentiments, temporal and social dimension enhance prediction accuracy and interpretability. Here, like racial BERTS performs demonstrated the strength of deep conceptual enabling with logistic regression, whereas logistic regression offers explainable outputs only. Temporal and social features adds complementary insights to logistic data. These results have implications for deploying scalable ethical monitoring systems. And also it's responsible for deploying requires addressing privacy, bias, and transparency, ensuring AI tool supports, rather than replace human-led mental health assessment and intervention. And then finally comes to the conclusion and future works. The research confirms that value of multi-modal AI for mental health risk detection with BERT achieves highest accuracy and in logistic regression, strongest interpretability. And also like when it comes to the further works, we'll use longitudinal data sets, attention-based temporal models, and graph-based social network analysis. Ethical safeguards remains critical here, particularly around privacy and informed context. The long-term goal is to integrate such models into a clinical assessed systems. And also it provides the real-time explainable insights for the mental health intervention while investigating the user's trust. And that's all about my thesis explanation. And thank you very much. Thank you.